Sai Ram. Dear learners, welcome to part 2 of playing with numbers of class 8th mathematics. In last class, we revisited the concept of place values, how a 2-digit or a 3-digit number can be written in expanded form. Whatever we discussed in part 1, that was something that you have already studied in earlier classes. In today's session, we will be taking up gaming with numbers. There were two friends, Steve and Oscar. They decided to play a game. Steve said, I'll ask you or I'll give you certain set of instructions and you have to follow that. Oscar agreed to it. Steve told Oscar to choose a 2-digit number. And it was also specified that whatever you choose, do not tell it to me. Oscar readily did what was asked. She thought about a number and she chose the number 39 and did not share it with Steve. Next, Steve said, reverse the digits to get a new number. Okay, I'll do that, was Oscar's reply. So she reversed the number and got 93. Then Steve said, add this to the number you started with. Okay. So Oscar, she added 39 and 93 and got 132. Next, Steve said, now divide the answer by 11 and there will be no remainder left. Fine. Steve had given this instruction and Oscar obeyed it. She divided 132 by 11 and got 12 as quotient with 0 remainder. She was quite surprised. She said, yes, you are right, but how did you know? So Steve said, that is a secret, but still I'll share it with you. What had happened? Oscar chose number 39. After reversing the number, she got 93. She added 39 and 93 and got 39 plus 93, that is equal to 132. She divided 132 by 11 and got quotient 12, remainder 0. And this is just what Steve had predicted. Let's try the same trick with some other number and see whether it is applicable to other 2 digits numbers also or not. If it is number is 64, on reversing it, we get 46. Next was add these two. When you add these two, we get 110. Next step was divide the sum by 11. So when we divide it by 11, we get 10. And what is the remainder here? Remainder is 0. So this particular trick is applicable to number 64. Let's try it with 17, 1717. On reversing it, we get 71. Add these two, we get 88. 88 divided by 11 gives 8. And again, the remainder is 0. Let us try to generalize it. Instead of taking any digits, let the 2-digit number be A, B. This is the number chosen. Now AB, how will it be written? In expanded form, it will be written as 10A plus B, because B is at the units place and A is at the tens place. And in last lesson, we had discussed this, that whatever is at the tens place, that digit should be multiplied by 10. Now, reverse the digits. When we reverse the digits, number becomes BA. Write it in expanded form. It will be 10B plus A. Now add these two. When we add these two, what do we get? We get 10A plus B plus 10B plus A. This will actually be 11A plus 11B. We can take out 11 common and we get A plus B. So when we divide 11A plus B by 11, we will get A plus B. Remainder will be 0 in all the cases. I hope it is clear how have we got this. So you can try the same with numbers 27, 58 and 49. Gaming with numbers continues. Let's look at the second trick that was played between Oscar and Steve. Steve said, again choose a 2-digit number and don't tell this number to me. Oscar said, all right. She chose number 38. Then Steve said, reverse the digits to get a new number. So on reversing, Oscar got 83. Then Steve said, subtract the smaller number from the larger number. So 83 is larger, 38 is smaller. Steve asked Oscar to reverse these numbers. So what is 83 minus 38? First is 13 minus 8 is 5 and 7 minus 3 is 4. Then Steve said, now divide the answer by 9 and I claim that there will be no remainder. Oscar had got 45. She divided it by 9. Quotient was 5 and remainder was 0. Oscar thought that Steve is very intelligent. So this is what had happened. Oscar had thought 38. After reversing the number, she got 83. When she subtracted 38 from 83, she got 45. She divided 45 by 9, which gave the quotient 5 with no remainder. And this is just what Steve had predicted. Let's try the same with numbers 96 and 47. So number given is 96. Reverse the digits, we get 69. Then subtract. On subtracting, we get 96 minus 69. So 16 minus 9 is 7 and 8 minus 6 is 2. Divide 27 by 9. 9 3s are 27 and remainder is 0. Let's try with 47. Number is 47. Reverse it. It becomes 74. If you remember, Steve had said, subtract the smaller number from the bigger number. So, 74 minus 47. 14 minus 7 is 7 and 6 minus 4 is 2. Again 27. So 27 divided by 9 gives 3. Remainder is 0. So this was the second trick that was shared by Steve. Let's see if we can explain Steve's trick by taking the 2-digit number in general form. Number is AB and here we will assume that A is greater than B. Reverse the digits, we get BA. First of all, AB, how can it be written? It can be written as 10A plus B. On reversing it, it becomes BA. How will it be written? 10B plus A. Subtract the 2. We will get 10A minus 10B plus B minus A. If you look at it, it becomes 10A minus A is 9A minus, it is minus 10B plus B. It will be minus 9B. 9 is common, we get A minus B. So A minus B is a multiple of 9. So whenever we are going to divide it by 9, there will be no remainder. So this is how Steve's trick can be explained. Now let us see if B is greater than A, then how do we do it? So if B is greater than A, number again we will take AB, which is written in the form 10A plus B. On reversing it, reverse the digits, we get BA. BA will be written as 10B plus A. Now how do we make out whether AB is greater or BA is greater? In the question it is given B is greater than A. So that means BA will be greater than AB. Whatever is at the tens place, we have to see that. At the tens place, B should be greater. So we will do BA minus AB because BA is greater. So if we do this, so let's write it. So 10B plus A minus 10A plus B. We need to subtract it. So what will come? We can do it in this way also. Let's copy the first thing. $10B plus A minus 10A plus B. Why have I put the bracket? Because we are subtracting the whole second number from the first one. So this will be equal to 10b plus a minus 10a minus b. What do we get? What is 10b minus b? 10b minus b is 9b. What is a minus 10b? A minus 10b is minus 9a. Again 9 is common. B minus a is there. Now if we divide 9b minus a by 9, we will get b minus a. Remainder will always remain 0. So whether it is a is greater than b or b is greater than a, in both the cases, the end result would be a multiple of 9 and hence there will be no remainder. And we had already done one question where b was greater than a. Let me take you there. Just see 47. So in 47, this is a, this is b. Here b is greater than a. In the first example that we did, here a was greater than b. In both the cases, remainder is coming 0. And what if a is equal to b? Let me take one number, say 99. You reverse the digits, what does it become? Again 99. We subtract them, what do we get? 0. You divide 0 by 9, what will be the answer? 0. Quotient will also be 0. Remainder will also be 0. So in all the three cases, whether a is greater than b, a is less than b, or a is equal to b, this trick is applicable. So home assignment, try the same with numbers 17, 21 and 89. I am sure you will be able to do it easily. That's all for today's class. Thank you so much. Om Shri Sai Ram.